junior data scientist from Outfit 7, who also has roots in academia, but is now in charge of development of personalization, matchmaking, and ranking systems in some of the world's top mobile games. He will talk about clustering player strategies for the generation of non-player characters. So let's find out how NPCs can make or break a game. Rok?
Okay, thank you for the nice introduction. My name is Rok. Once we get this mic to work, is it okay? Okay. So we got a really nice overview from Konrad about this high-level overview about what is possible today with AI in the games. Do we switch to normal mic? Okay, so we got this really nice high-level overview of what is possible today. I'm going to talk about similar topics, but I will pick a simple problem and I will go in depth to show you how we can solve things. So what we'll talk about today are three things. One is clustering, so machine learning. Then it's strategy in the games. And finally, how to generate non-player characters. So the plan is I first introduce the game to show you what strategy in these games means. Then I'll explain the problem that we're trying to solve, how to generate non-player characters, and finally how I used clustering in order to do that. So let's start with the game. It's called Mythic Legends, and basically what you do in the game, you have battles in this arena. How you play these battles, what you do is actually you put these champions that you see on the bottom of the screen in the arena, and then you start the battle. Now you see here I have a legend on level 6, this guy with an X, which means I can pick 6 champions. How I do it? Maybe first I pick a knight. This one is really good because it has a lot of health, defense, so I put him in the first row, so he will protect the other champions. But its problem is that it doesn't do a lot of damage, so I need to find some other class that will do that. And these are Blade Masters, they deal a lot of damage, and they still have good health, so I put them in the first row. I picked 2 of them. I have a third one, but it's on level 1, so I don't want to use it because it's weak. And I turn to another class, for example, these Rangers. Rangers also deal a lot of damage, but the problem is they don't have a lot of health and defense. So I need to keep them in the back row, protected, so they can deal some damage while they are still alive. What if my opponent has these Rangers? Well, then I have the 4th class called Assassin, and its superpower is that at the beginning of the battle it will jump in the back row and attack the opponent from behind. And this is basically the strategy. As you see, you have 2 things to think about: which classes you will pick and how you will strategically position them on the board. Once you're happy with this, you just press battle and it goes automatically. You don't control the characters during the battle. At the end, one player wins. The losing player gets some damage. It's actually not just a single battle, it's a tournament. Here we see a tournament with 6 players, and towards the end of the tournament, some players are eliminated. Then, depending on how well you do in the tournament, you get some rewards, so you can upgrade your champions and legends, and you get some experience, so you move through this progression map to unlock new arenas, new champions, new legends, new game modes, get some additional rewards, and so on. So now we saw how the player plays this game. Who is the opponent in this game? It's a multiplayer game, but a multiplayer game with a twist. It's asynchronous multiplayer, which means you're playing versus people, but not the people that are currently online. How this works is after each tournament, game sends the recording of what the player used, kind of a snapshot or a ghost or a recording, into our database. And then once we need to do a matchmaking, we look at the matchmaking configuration and according to it, pick appropriate snapshots for the opponents. Why this is good? Because then player can stop in the middle of the tournament and the opponents that are actually snapshots, not real people, don't even notice that somebody stopped playing the tournament, so there's no problems with it. Another good thing is that we don't have to wait for players to be actually online, because we have them in database, recordings in the database, and we have a lot of these recordings, so we can do accurate matchmaking at any time, even for the top players, which would otherwise have few opponents. Okay, so now we know who's the player, who's the opponent. Now let's see what the problem is. The problem was that we wanted to add a new game mode to this game, and my task was to adapt this matchmaking to work in this adventures event. What I start with is game design document. This slide just shows you that, yeah, it's long, it's a lot of text, but basically it's just rules that the game designer came up with, and then UX designer made this flow, all the screens for which people will go when playing this game mode. What I first need to do is translate this into actual requirements for matchmaking. And what are those? I managed to sum them up into 4 things. What this game mode will look like, you'll again have a map for which you'll progress, but you'll go through steps on these islands. Each island will be a single battle, not a tournament, just a battle, and you can progress even if you don't win, if you have enough health. Now what game designer wanted to do is that each next island, each next battle would be more difficult. So what this means for matchmaking is that it must be accurate and it must be configurable. So I said, okay, maybe with a bit of thinking I can tweak my matchmaking to do this. The second thing that game designer wanted to have is that people would use small formations, maybe 3, 4, 5 champions, and that they could use any champion. Opponent could use any champions, even the ones that are unlocked later in the game. And what my problem is that I don't have snapshots, because people that have unlocked champions in the, I don't know, 7th or 8th league play with 10 to 15 champions, not with 3 champions. So this is my problem. I don't have snapshots that I could use. And I have an additional problem that some of these battles will be encounters or boss fights. And how game designer imagined it is that it wouldn't be a normal battle, it would be a special battle. Maybe instead of some champions, you would have dragons. In boss fight, you would have one huge dragon, and maybe one champion would be duplicated, or maybe there would be 5 copies of the same champion, so something that player normally can't use. How they came up with this idea? Well, basically we had a game mode that was something like this. It was kind of a puzzle, very special formation that you really had to try hard in order to beat. And then I said, okay, if encounters and these boss fights can be templates, then even for the normal battles, maybe we can also use templates. So I translate the problem from getting the snapshots into generating templates from which we'll do snapshots. So how this template should be, this was another requirement, that this game mode should be more fun than the regular classical mode, so more diverse, more interesting, and that it should serve kind of as an extended tutorial. So the opponents would be really smart and they would teach the players, the engaged players, how to play the game better. So I need really smart templates from which I'll generate actual formations for the opponents on each of those islands. And this is now my task. How I'll do it? Basically, this is the idea. I need to generate these templates that you see on the left, and they only tell you which classes are used and how they are positioned. Here I have 3 knights in the front row protecting the other champions, 3 rangers in the back dealing damage, and 2 blade masters on the side that will take care of assassins, zombies, and anything else that might come into the last row. So what I need to do when I have this, I just pick a formation with the configured number of champions, and then I need to assign to each class actual champion. And the last thing is I need to set the levels of these champions, and I do this so they're comparable to the strength that the player currently has, plus minus this difficulty tuning, so each next battle will be a bit harder. So yeah, now my problem is how to generate all of those templates. And I will need a lot of them. like at least 100, but optimally around 1,000 templates. How I could do it? Well, the normal way would be level designer does it. He knows how to play the game, so the templates will be smart, but maybe not the most unusual and diverse because they will come from a single person who knows the game. So my idea was, okay, we have thousands of players playing thousands of battles, we have a lot of snapshots. Can we use these snapshots to generate the templates? And a simple idea would be just to take the most frequent snapshots, which wouldn't be good because their skill is mediocre, so you couldn't learn nothing from them, and they wouldn't be diverse because most of the players use just the most common strategy. Better idea would be to take the top winning rate formations. They would be smart, they would be more diverse, but the problem is that we actually don't have the data about how well they perform because the player before the tournament sees the opponent and can tune his formation according to opponent. So the best players have very, very high win rates. And actually, if I did this, I would get just the best players, but their formations are good against a specific formation, against specific opponent, not good in general. So what I suggested is, let's cluster these formations. Do you guys know what clustering is? If not, this picture is trying to explain it. If we had a lot of pictures and I clustered them by color, I get 4 groups. The green group, blue one, orange one, and the purple one. I'll do the same, but instead of taking pictures, I'll take actual snapshots, actual formations, and I won't cluster them by color, but actually according to this strategy, which champions are placed and where. And then, when I have these clusters, I just pick one template from each cluster, which will guarantee that all the templates are very different, because one is coming from each clusters, and clusters are very different. And when I'll be picking them, I can pick the ones that look good, are diverse, and are smart, maybe according to their win rates or something else. So now I translated this problem into actually clustering existing snapshots. How I'll do the clustering? I have the data, I have the machine learning algorithm. What it needs is a distance metric. Distance metric will actually look at two formations and tell us if they're similar or very different. And if you look at this example, you see two formations, and maybe because you don't know the game, they look very similar, but actually they're very different. Just the placements are similar, but if you look carefully, you'll see that all the champions are different. So we want this function to say this is a very big distance between these two formations. These 1 and 3 maybe don't look so similar, but they actually are. They use the same champions, but just placed in different positions. So I want this function to say, aha, this is closer. And maybe this 1 and 4 would be the closest. The first row is the same. In the second row, I see just the 2 rangers are moved to the sides, and this middle one is moved 1 tile back, and is also changed from what we have here, from ranger into assassin. So how do I write this function? If I put myself back in my two old shoes of AI researcher, I would turn this into a 6 months project. I would have a lot of fun doing it. If I had funds, I could spend a year on it. But my product manager said, okay, we can do this your way, but can you do it in 2 weeks? And of course I said, yeah, I'll make it in 2 weeks. Before I was aware of all the problems. But because I knew that I don't have a lot of time, I said, okay, let's simplify things. What do we know and what is simple? If I only have 2 champions, it's easy to compare them, right? I look at their stats and just look at the differences, and this will tell me if the champions are similar or different. The other thing that I know is if I ignore champions, I look only at the positions. This first row that has the same positions didn't move. I say this is distance 0. In the second row, these rangers that moved left and right, I just count the number of tiles for which they moved. They moved 1 left or 1 right. The only thing that I don't know how to deal with is this middle one that changed from assassin to ranger and also moved. So I need a solution for this. How I do it, how I cluster it, this is the basic idea. First I said, I don't want to cluster champions with different numbers of formations. So I split all the formations that I have and first cluster the formations with 3 champions, and then with 4 and 5 and so on. And then I'll split clustering into 2 phases. In first phase, I'll ignore positions. I will only look at the champion classes. So maybe I'll get a cluster with a lot of knights, green cluster with a lot of blade masters, yellow cluster with a lot of rangers. And then in the second step, I will ignore the classes and I will only look at the positions. Why I can do this? Because I'm only clustering the formations that are very similar, have the similar classes. So I can ignore this and just cluster by positions. So how do I do this first step? First I need a distance metric between champions. I look at the stats and compute effective health. This is not just the basic health, but it adds the defense and healing and effective damage. This is not just the normal damage, but also includes critical hits and things like special abilities. I calculate this for every champion, average over each class, and then I have to normalize it. Maybe subtract the medium value and divide by standard deviation. And then if you compare this red ranger on the top, you see it's close to assassin. It does a lot of damage, but it doesn't have a lot of health. But if you compare it to knight, bottom right, you see that they're a lot different. So now I can compare 2 champions, right? I look at their stats, put them in this space, and just measure the Euclidean distance. How do I compare actual formations? Here I have 2 formations, red and blue, with 4 champions each. Well, I can look at all the distances and then make pairs. And how do I make those pairs? So that the sum of the distances will be minimal. What's the problem with this approach is that if I had 10 champions, I would have millions of combinations, and this would be very slow. What I need to do is take million snapshots and compute distances to million other snapshots, and computing distance for each would take million comparisons. So this is not realistic. I have to simplify again, and I use greedy approach. Do you know what greedy is? We'll make choices iteratively, one by one, and while making each pair, each choice, we'll only consider what is important now and don't care what's later. So an example, first I notice that I have a shapeshifter in both of the formations, so I'll make this my first pair and say distance between those 2 shapeshifters is 0. Then in the next step, I need to find a pair for the assassin, and I could pair it with a ranger, with priest or knight, not with the shapeshifter because this pair is already taken. I see that ranger is the closest, and I just remember this. I continue to the beastmaster. I can link it with 2 remaining champions. I see that knight is the closest, and in the last step I don't have any choices. I just measure the distance, and then I put all this thing together, sum this up. I see the distance is 2.1, and now I can do the clustering. Is this okay? Well, because it's greedy, it's not perfect. Here you see an example. The perfect matching would be these green lines, but I actually get these yellow ones. Can I live with this? Yes, I can. The differences between optimal and the greedy approach won't be big, so it doesn't bother me. Because if formation is close to a cluster center, it will be still close even if it's a bit further away. And if it's somewhere between 2 clusters, then again, I don't care in which cluster it will fall. But it's much faster. For big formations with 10 champions, this greedy approach can compare in 1 second as many formations as the optimal approach would compare in 1 day. So I have much faster algorithm. I can do a lot of iterations. I can fit everything in these 2 weeks that I have. And it's still accurate enough. So we've done this first step of clustering by champions. Now we need to do the second step, clustering by placements. And as we saw before, if champion didn't move, we say distance is 0. If the same champion moved, we just count the number of tiles for which they move. This is called Manhattan distance. And then before, you remember, I had the problem about this ranger that was changed into assassin. How do I deal with this? Well, basically, these 2 formations, the first step told me that they're really similar. And then I can just ignore that this is a different champion because it's so similar that I just compare the distance and say, okay, this champion moved for one tile because it's still a very similar champion than before. Again, an example of how I do it. In order to avoid this combinatorial explosion, I again will need this greedy approach. And from the first step, I will already get the champion pairs. So in the red formation, I have 3 knights. One is matched with a blue knight, the other ones with 2 beastmasters. And then I have a blade master connected with assassin. How do I compute the distances? I overlay these 2 formations, and I notice that both of them have a knight in the first row, so this will tell me this distance between these 2 knights is 0. Then the next knight must be matched with a beastmaster. I have 2 choices. I see that one is closer. I make this choice. Move on to the next knight. There is only one choice, so I only measure the distance. And in the 4th step, blade master and assassin, I don't have any choices, so I just measure the distance and then sum up all the distances, and I see the difference is 4. And then I'm done with clustering. What I have now is I took these millions of formations, split them into the number of champions, then split them according to what champions are used, and then I got a bunch of blue clusters. In each of those blue clusters there are formations with very similar champions and very similar positions, and from each of those I will pick one formation. How do I do this? This is my final visualization. This is clustering for 3 champions, 2 knights and 1 assassin, and I have to pick one formation from this. And maybe to you this looks complicated, but we've been looking at this for 2 years, so it's really easy. I know 2 knights, they should be in the first row to protect other champions and to start dealing damage as soon as possible. So I look at this purple cluster in the 3rd row, and I need to pick one formations from there. I could pick the one with high win rate, or I can pick the one that looks good. Maybe this 4th column in the 3rd row, this looks symmetric, this looks nice, I pick this. And instead of game designer actually thinking about all of this and then writing down the templates, I just click here. Game designer sees all the knowledge of all of our players and can pick appropriate formations. This of course becomes a bit more difficult if you have a lot of champions, but still, you know the strategy, you know if for this particular set of champions we should use the back row formation, the corner formation, the arrow formation or whatever, and then you just pick one. For doing this manually, we actually learned a lot. We learned a lot about which strategies our players are using, and according to this, then we could even tune our champions, their stats, and introduce new classes that would counter some formations that didn't have good counters before. And so I translated this problem of matchmaking into actually picking template formations, and from them we'll actually generate actual formations. And so we're coming to the treasure chest at the end. What I was trying to say between the lines. The first thing was that you need to really well understand the goals of your product, because otherwise you don't know what you're doing. The second thing is that you have to know your product really well, so you can reuse the knowledge, the concepts, the code that's already existing. Like we reuse templates, we reuse this algorithm for setting the levels, we reuse the knowledge, the data about the snapshots that we already have. And then the next step is translating like requirements into actual machine learning task. So I translated this game design document, couple of pages, into a task that tells me, okay, cluster the formations. And then what I had to do is, you saw I did a lot of simplifications in order to make this quick, but still good enough. I used data when it was possible, but at the end, we were picking the formations from these clusters manually. I could do it automatically, but it would take me a lot of time to code this. And if we did it automatically, we also manually, we also learned a lot for doing this. So use your domain knowledge where it's fit. So this was my presentation. If you have any questions, I will happily answer them. If not now, I'll be here for the other 3 days, and you can find me, and I'll be happy to talk to you.
Thanks for the presentation. Looking back at the scatter plot with DPS and health, I was just curious. I see the classes were like grouped in the corners, so the middle was a bit of blank. Are you using the same approach maybe for balancing out the classes?
Not really. For balancing classes, what we do is we have simulator, and then game designer designs a new class, and then puts it into simulator, makes, I don't know, 20 formations with this new class, and then tries different formations and see how well they do it, and they balance it based on this. Once we're satisfied with this, we do an update, we ship this, and then we do analytics. We measure things, what people are using, how they are playing, and then we tune according to it. And we have often, in this special game mode that I showed, as a reward you can get champions that you can get nowhere else in the game. You can buy them, you can unlock them, you can just get this in this event. And this is kind of a playground testing for new champions. So we can put them in this mode. There are special champions that can be tested for a month or two, and then we can tweak them, rebalance them, and then when they go, they become available in the general game, they're already tuned. So two phases, in the simulator and then in the preview, and then finally it goes into game, and with updates we can do further tweaks. But yeah, from observing these formations, we learned about strategies, which strategies don't have good counters, and then we could introduce new champions or notice some overpowered champions and then tweak them accordingly.
Thanks.
Anyone else for one quick question?
Maybe a very quick one, like it's more related to the product side. Then what's the success criteria that you did all this?
Well, success criteria is the players that actually come into this game mode, do they stick with it, right? We get the data, but it's a bit biased because some people are playing this just to get the champions that they can only unlock in this game. But yeah, we can look at the stats and see the people that try this game mode once, do they keep playing it? And the other thing is the people that play this game mode a lot, do they become better later in the game because they saw all those smart formations and maybe learn something from it. So I can look at the people that play this game mode a lot and their win rate before playing this and after 2 weeks or a month of playing this, is their win rate going up, and are they using more diverse formations than before playing this game mode? So this would be the success criteria. And another one is, by me doing this job, I saved 2 weeks of game designers' work. So they could focus on designing new game modes, not on doing this trivial stuff. Thanks.
Thank you, Rok. And here is a certificate of appreciation for you.
Thank you.